In this video, we're going to talk about maximum flow in terms of networks. When we're thinking about maximum flow, we're thinking about the amount or the capacity of something to flow through a network. If we take these two, for example, real life situations where this is talking about water flowing through some pipes. If 150 litres can flow through the first pipe and 400 can flow through the second pipe, how much can go through the whole network? Well, we need to realize that only 150 can go through the first one, which means only 150 can enter the second one, which means only 150 can exit. So it doesn't matter that the second one can still hold 400. We can only get 150 into it, so only 150 can go through. The same goes for the second one. If there's 700 litres that can flow through the first, but only 120 that can go through the second, then only 120 can actually leave this network. So what you'll realize is the lowest number in the network, or in this one in particular, is going to be the one that, or the number that can actually flow through. If you think about this example for airlines and planes, let's say 150 people can get on the first flight, but the second flight can carry 400. Well, how many get to the airport? Well, obviously only 150 can get there because only 150 can get from the first to the second. So it doesn't matter that there's 400 seats on here, only 150 people can get there. Same goes for the second example. If this first plane could carry 700 people, but the second can only carry 120, then only 120 are going to enter the destination. It doesn't matter that 700 could get to the first place, only 120 can actually get onto that second plane. Hopefully that makes you understand a little bit about maximum flow. Maximum flow and network flow involves directed graphs. Remember, directed graphs are just networks that have directional arrows on the edges. When we're talking network flow, a couple of things to remember is that the source and the sink is also known as just the start and the finish. So that's all you need to know for that. And the maximum flow is found using cuts and logic. And let's look at how to use that to find the maximum flow of a network. To find maximum flow using logic, what we do is we follow a process for every single one. In that process, and we'll go over this on the next slide in terms of an example, but we need to identify a path from the start to the finish. We find the edge with the lowest capacity on that path, and then we subtract that value from all of the edges on that path. Simple as that. We highlight the edge that's now got a capacity of 0, and then we just repeat the process for the next path until we can continue and we cannot flow through the network anymore. All of the recorded capacities become the maximum flow. So let's look at what we've just talked about in practice. Here's an example. If we choose a path going from the start to the finish, and we choose this one in particular, what we see is that 300 is the lowest on that path. So that becomes 0 because we subtract 300 from all of them. This becomes 300 and this becomes 500. Because this one has become 0 from 300, we write 300 for the flow here and we highlight that edge. We then need to find another path. Well, if we follow this path, down, up, down, we can go through there and we realize that 500 is actually the capacity of all of those edges. So all of them become 0 because we have to subtract the minimum value of all of them. We write 500 over here. That of course says 300 plus 500. And remember, we have to highlight one of those edges. If we've made multiple edges 0 in the one path, we just highlight one of them. What we now realize is we can't actually get from the start to the finish any other way because we need to cross edges that are already worth 0. So we can't get there. What that means is that we put an equals and the maximum flow for this network is 800. Let's do one more example. We're getting from S to T. If we go to the top one first, The minimum capacity on that path is 3, so that becomes 0. This here becomes 5. We highlight that one, and over here we write flow, and of course the first one is 3. The next path that we can take is going from S to C to B to T. The minimum on that path was 3 again. We make that 0. We make this one 2. We make this one 8. Of course, we highlight C to B and we write 3 over here. There's one more way that we can get from S to T, and that's down this path here and that path there. We see that 1 is the minimum on that. We make that 0. We take 1 away from 8, that becomes 7. We write 1 over here, and of course we highlight that edge. What you'll now see is that we cannot get from S to T any other way. This direction here prevents us from going down that. So for this graph, the maximum flow is 7. Hopefully those examples have made sense to you. Remember, you can re-watch them and break them down and pause them if you need to.